Hi everyone, Assalamualaikum. In this video, we will discuss example 1 from previous semester papers, June 2019, question 4C, 8 marks. Find the general solution of the homogeneous differential equations dy over dx equals to y squared plus x squared plus xy over x squared, right? Okay, from here we have y squared, x squared, x the power of 1, y the power of 1, and denominator x squared. Okay, and this is same degree, alright, which is degree 2. So we can solve using homogeneous equation, alright. When we solve using homogeneous equation, step 1, we write dy over dx as a subject and name as equation 1, alright. We are given dy over dx as a subject, okay. Then we name as equation 1, okay. And then step 2, substitute dy over dx equals to x dv over dx plus v and y equals to vx into equation 1, alright. Then we get this, okay. So we replace dy over dx equals to x dv over dx plus v from this equation, okay. We replace y equals to vx here, and y from here we replace by vx, okay, from this equation, right? And after that we simplify, so we get this, okay. And then step 3, factorize and simplify x squared, okay. If we have homogeneous equation with degree 2, we can simplify x squared, right? So from here, okay, we have term containing x squared from numerator, okay. So we can factorize x squared here. So in bracket we have v squared plus 1 plus v, okay, and denominator equals to x squared, okay. From here we can simplify x squared from numerator and x squared from denominator. So after we simplify, we have x dv over dx plus v equals to v squared plus 1 plus v, okay. And then we can solve using separable equation, okay. So we continue with step 4, separating variables v and x, okay, because from here we have variable v and x, okay. So when we want to separate, we can follow BODMAS, okay, but in backwards, okay. So we need to separate subtraction and addition first, okay. So from here we have plus v, so we can move to right hand side, okay. So we have x dv over dx equals to v squared plus 1 plus v and then minus v, okay. Alright, in step 4, after we simplify, so we have x dv over dx equals to v squared plus 1, okay. Okay, and we can write x over 1 dv over dx equals to v squared plus 1 over 1, okay. And from here we have division and multiplication operation. So we can move variable v to left hand side and variable x to right hand side, okay. So we can move dx from denominator here, we move to right hand side, okay. And then x from left hand side here, we move to right hand side, and v squared plus 1 we move to left hand side, okay. Then we get this, okay, 1 over v squared plus 1 dv equals to 1 over x and then dx. Alright. Now we done separate variable x and variable v. Okay. So after that, we can continue with step 5, integrating both sides. Okay. So from step 4, we just put integration sign for both sides. Okay. So now we have integration of 1 over v squared plus 1 dv equals to integration of 1 over x dx. Okay. And then when we integrate 1 over v squared plus 1 dv, okay, we have inverse tangent v. Okay. This comes from integration of 1 over 1 plus x squared dx, which is equals to inverse tangent x plus c. Okay, so when we integrate 1 over v squared plus 1 dv, okay, we get inverse tangent v. Okay, and then we integrate 1 over x dx, so we have ln x plus c. Okay, and then step 6, we replace v equals to y over x. Okay, so the general solution is inverse tangent y over x equals to ln x plus c. Okay, we replace v here, okay, equals to y over x. Okay, alright, we stop here. This is the final answer. Okay, we don't need to find the value of c since the initial condition is not given. Okay, from this question. Right, so this is the final answer. Okay. Coming up next, more examples for homogeneous equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.